120 attendees and more connecting, but let's start to be on time. This is a webinar organized jointly by the European Heat Pump Association and the European Heating Industry Association. My name is Mélanie Auvray. I'm a senior EU Adfair advisor at the European Heat Pump Association, and I'm working on eco-design energy labeling dossiers. But today, it is my pleasure to open and moderate such an interesting webinar. We will discuss about the role of thermally driven heat pumps in the decarbonization and reaching out the climate neutrality by 2050. So moving on to a few rules for the participants. The cameras and microphones are off. You can react using the buttons that you see up. During the Q&A, you can ask questions using the chat function. We encourage you to name the speaker when you're addressing your question so that it is easier for us to direct the question. The webinar is recorded. We will share the recording and the presentation afterwards on EHPA and EHI website, and we will do a follow-up email so that you receive all the links necessary. Moving on to now the agenda. So we will start with a short introduction by both Secretary General of our association, and then we will move on to a short presentation of the technology reports on thermally driven heat pumps. And finally, a panel discussion on which we will focus on the role of thermally driven heat pumps in the decarbonization of heating. And now you have the main information, I think, to this webinar, and I see more people connecting still, but let's start with the introduction by both Secretary Generals. Maybe we should start by Federica Sabati, the Secretary General of the European Heating Industry Association, EHI. Federica, the floor is yours.
Thank you, Melanie, and good afternoon, everybody. Thanks for hosting this event with us for EHPA, and thanks for all of you to attend. I would just say a couple of words of welcome. I think a lot has already been said about the structure, but I think what I still wanted to bring on the table as a framework of this discussion is that decarbonizing buildings still remains one of the most difficult things to do, one of the most difficult sectors to decarbonize. This is because buildings are very different from size, insulation levels, climate, where they live, where they are located, the energy infrastructure where they are located, but also the economic availability of their owners or their inhabitants. So it's still a very difficult sector to decarbonize, even though in the last few years it has gotten much more attention from policymakers to see this challenge, to transform this challenge also in an opportunity. As buildings are very different, so are heat pumps. There's different type of heat pumps. So the focus of today's meeting is to deep dive into one of the technologies that are a bit perhaps less known in the heat pump field, thermally driven heat pumps. They are not less interesting for that, but they are a little bit less known. And so together with the HPA, our experts wrote a paper that describes how they work, how they function, what is their role, what type of buildings are they particularly suitable to decarbonize. And this is a little bit of the starting point of this event today. And then the idea is really to present it and then discuss with the panel that we have today, which includes also policymakers, but also with you to discuss a little bit about the technologies and their potential. So I just like to thank again all the organizers for this event, which I very much look forward to. And I pass the floor to my colleague, Thomas Novak from EHPA. Thomas.
Thank you, Federica. And indeed, buildings are very, very different one from another, and they need still good heating solutions. I would like to agree with you to thank all the providers of information for this meeting. I want to thank especially Melanie, who has pushed this project forward. And it's really not a very new project, in fact, because we have started in EHPA to push for more variations of heat pump technologies probably 10, maybe even 12 years ago. That's when I met Luigi for the first time, and he was still with another company, and we looked at the refrigeration cycle, saw adsorption and absorption. I mean, very weird terms if you're coming from a policy background, and it's even more complicated to understand what they are doing. And maybe it was also quite complex for the manufacturers, because we saw quite a few manufacturers come and go, offering products, announcing products. I remember in 2018, there was a big announcement at the ISH. There was supposed to come a big player to market with thermally driven heat pumps. And we were all very happy, because we also went to the commission and said, look, see, this is not only electric heat pumps, it's a variety of technologies. We could add piezo electric heat pumps and thermoacoustic heat pumps and reverse cycle heat pumps. So there's a number of other variations. The number of players, I think, now is back to a solid level of people that really want to do something. And hence, I'm very happy about this meeting as a stock taking of where do we stand, what can this industry really deliver, and is it the most efficient boiler, the most efficient technology to use molecules when it comes to provision of heating to buildings. And that's what we hope to see out of this event. We have, this is the presentation of a white paper that we have jointly prepared. And I hope that this helps everybody to understand better, A, this technology, B, that there is more technologies than only electric, and C, that there is the need for development also in this field, because we're really only at the start. If we would have to present market data for thermally driven heat pumps, it would be a small number. And hence we have to keep that in mind. If the market is very big, and we will hear about that a bit in the future, then it will probably require an even faster deployment of this technology than of others. And then we have to see, is that all feasible? But anyhow, I wish us a great afternoon and a good starting point of the discussion.
Thank you both for the brief introduction. I think now this is time to move on to the presentation of the technology report on thermally driven heat pumps. Gerrit Kudler, the head of the group Thermal Integration at Fraunhofer Institute Solar Energy System, will give this presentation. Gerrit is the chair of EHPA Thermally Driven Heat Pump Working Group, and he has coordinated the drafting of the technology paper that has been published a few weeks ago. In case you haven't read it yet, please have a look on our website. Gerrit, the floor is yours.
Thank you, Melanie, and good afternoon to everyone. Welcome to this webinar, and I'm very impressed. There's now more than 170 people connected here. That is quite a number, and as Thomas already wrote in the chat and said, it shows that there's quite some interest in this technology and it can do. And I will quickly run through some slides. What are thermally driven heat pumps? Sarah, you want to hand me over the presenter's rights? Then I can flip myself.
Yes, you just need to click on take control at the top of the screen,
Yeah,
but otherwise
I got it.
I can do it. Yeah.
I got it there. There we go. All right, so let's start. Before going to the technology, just some considerations. What are we facing in the future, and what is the current situation, and what is the challenge in heating houses, heating homes in Europe? This shows the example of Italy, and the average energy consumption for heating of residential homes per square meter and year. And what you see here, the average is still about 180. Italy, in this case, is a little bit lower. Sure, there is not too much heating need in some parts of Italy, but some parts are still heavily depending, especially on gas heating. And as you can see on the next slide, Also, the existing buildings situation is usually, and this counts for many European countries, it is the case that many existing houses are not too much renovated, not too much retrofitted, and have still quite a high energy need for heating. And in Italy, it's more than 50% of the buildings that are in the category F and G, which is the worst categories for energetic efficiency of buildings. And this is a big challenge, and this is what we need to quickly face within Europe to really reduce CO2 emissions quickly. Another thing that comes with it is what I already said. Currently, still a lot of energy provision is today done by natural gas. You can see a year in Italy that in 21, it was very obvious that in wintertime you need a lot more energy, specifically gas, in final use, and even more if you see the if you take the upper blue line. What you also see that of course also quite a share of electricity that then goes into the buildings is currently still produced by burning gas. And while the energy demand for electricity currently is much lower, and this is basically the same picture for many European countries, for Germany, for the Netherlands, it looks pretty much the same. And the big question is, how can we change the heating of our homes, and how can we reduce the energy consumption for doing so? And one option that we want to look into here a little bit more in detail is the thermally driven heat pumps. Very roughly, a quick explanation what this means. Typically, when talking about heat pumps, people talk about vapor compression heat pumps. They take mechanical work, which is delivered by electricity that is driving a compressor. They take a lot of renewable heat from the ambient, and they deliver it for heating of homes and also for domestic hot water production at a medium temperature level, which can also be higher, but usually they perform best when the temperature levels stay low. Actually, the same is the case for thermally driven heat pumps. They also perform best when the temperature levels stay low. But what they do, they have a thermal compressor, basically, and what this is more in detail, we can discuss later. But it's it takes a gas burner, for example, but it can also take other thermal energy that runs this thermal compression cycle. It also takes ambient energy, heat, ground source heat, air, or other ambient heat, and it delivers heating. The temperature levels that can be delivered with still a heat pumping effect and a decent heat pumping effect are a little bit higher than for the compression heat pumps, for the standard residential compression heat pumps at least. And they don't drop as quickly in efficiency. Starting from this understanding of this technology, another view on how we heat our homes. We have the typical wall-hung boilers, the gas condensing boilers. They take currently usually natural gas. They run the boiler, they have some losses, and then they basically more or less deliver maybe 90–95% of this in form of heat to the building. A vapor compression heat pump takes electricity from the grid, which can be renewable and will in future be more and more renewable, but currently also is done by coal plants or by gas plants. It's just the typical mix in the grid. In this example, we use the primary energy factor of 2.5, which is, well, an average. It is now being discussed to be lowered for the whole EU, and it differs a lot between maybe 1.5 currently and up to 3.5, depending on country, but also depending on season and on place where you are. This electricity is taken. Well, this primary energy is taken. Electricity is produced, and from this electricity, you can run the heat pump. Here, COP of the heat pump of 3.1 is assumed, and you get in this calculation then 125% of the heat you put in on the primary side. And these figures are examples. As said, they can change depending on the boundary conditions. And for the thermally driven heat pump, you take gas or an energy carrier that you burn, you get via the heat pumping process additional ambient energy. And in this example, with the typical efficiency of this technology, you basically get a similar primary energy efficiency as a compression heat pump. There are already heat pumps, thermally driven heat pumps on the market. And as Thomas pointed out, market numbers until now are quite low. There's typical examples for the absorption technology shown here. Absorption implies that it is a liquid sorption process. The liquid solution is continually circulated. It is desorbed and absorbed. The refrigerant is usually ammonia in this case, and with a low global warming potential. Usually they use a directly fired generator to run the heat pump process. And it's probably the most commercially mature TDHP option. There is another typical option also for a sorption heat pump. It's the adsorption process. It's a batch process with solid sorbents, and you, again, for example, have the refrigerant ammonia there. There have been in the past examples for the refrigerant water. They had issues, especially when it came to use of low temperature heat, which is ambient air and which needs to be used also at temperatures below zero. One maybe a bit of an advantage of the adsorption technology is that it can be more easily configured as a hybrid solution, where you also can use the gas condensing boiler directly, and at points where you need really high heating powers and high temperatures, and you basically have a hybrid solution. Then the technology readiness level is that they are currently in field testing. There's other technologies for thermally driven heat pumps, which I will not go into more in detail now, both due to time restrictions, but also because they play less a role for residential heating. This is the gas engine heat pumps. They basically use a gas engine that runs a vapor compression cycle. It is also a thermally driven heat pump, but as said, usually more used in industrial applications or for cooling, which we will not dive into at this point. What are the challenges for this technology? It's basically similar as for the electrical heat pumps. For example, that you need a space for an outdoor unit, either for the full heat pump or getting the ambient air. And there might be regulations around the use of the refrigerants for ammonia, and especially there are some regulations. It is definitely the case that these options, since they, in addition to any type of combustion system, they have the heat pump system. So the form factor or the footprint is larger than competing options, and thus related also the fully installed costs are usually higher than for a gas condensing boiler, at least. One issue that is a big challenge and that we might also address now later in the discussion is that the perception of this technology is that gas is the past, or we don't want any gas appliances anymore. We want to completely electrify our heating, and that of course helps. Doesn't really help this technology to become a significant player in the energy conversion, in the system conversion, and in reducing the CO2 emissions. And another thing that we might also tackle with this workshop a little bit is the awareness of this technology. Installers, end users, policymakers do not really know this technology, and this also is a challenge. It is key that these technologies provide a certain flexibility and, as said previously, that they can tackle the big issue of retrofit of existing buildings, of reducing energy consumption, primary energy consumption of existing buildings. So, and that is, let's say, a little personal view. I would say, we would say that they quite intimately link efficient technologies of a condensing boiler and a heat pump cycle, which is the big difference to a typical hybrid heat pump, which has one gas condensing boiler and the compression heat pump next to it. It is really one appliance that basically in all operation points does a certain heat pumping. They are suitable for high temperatures, for typical high temperature heating systems, quite abundantly to be tackled within many European countries. Typical radiator heating systems needing supply temperatures of 55, 60, or even more degrees Celsius at low ambient temperatures. They do reduce the use of fuel by, for example, 30 to 40% compared to a condensing boiler. And they do this by adding renewable energy by heat pumping. They do make use of currently existing energy infrastructure, and they would immediately reduce gas consumption if installed now. And if in future fully powered by biogas, well, call it renewable gas or whatever, if this comes, of course, they on the one hand use 100% renewable energy, but still they make a very efficient use of this then probably quite valuable resource. So with this introduction on the technology, I would like to give the word to Stephen Ashurst, and I would like to ask the panelists to discuss a little bit. And I think, Stephen, you have prepared some questions, and I give the word to you. Thanks.
That's great. Thanks, Gerrit. And thank you to the EHI and the EHPA for inviting me to be involved. My name is Stephen Ashurst, and I'm the Head of Heat Research at LCP Delta, formerly Delta EE. And I'll be moderating our panel session, which will last for about the next 40 minutes, I think 40 minutes, in which we'll hear a range of perspectives, so from some really excellent contributors from the policy level, at the European level, to some more specific countries where there's really interesting activity or potentially activity with regards to rollout of thermally driven heat pumps, or TDHPs, as I'll most likely refer to them throughout. And yes, there'll be time for Q&A and potentially a poll or two at the end of the session as well. Can I just remind all of our panelists that we're looking to keep to about 3 minutes per key point. So I will come in and nudge you along if that's required. But without further ado, I'd like to begin by bringing in our first panelist, Eric Lecomte from the European Commission. Specifically, Eric, you are a policy officer within DG Energy, NRB5 at the European Commission, if I'm correct. You've actually just led a report looking at the competitive situation for all heat pump technologies across Europe, which did include thermal driven heat pumps, obviously, TDHPs. And I guess we might as well get cut to the chase. My first question to you is that, say, if we assume or we appreciate that X% of building heating will be decarbonised through the electrification, Y% district heating and heat networks, but there will still be this Z% of gas-based heating in Europe by 2050 beyond. What is the European Commission doing to support the introduction of technologies like thermally driven heat pumps along with other heat pump options? Over to you, Eric.
Yes, can you hear me?
I can.
All right, perfect. So thank you for inviting me to this very interesting and very well attended webinar. Also, thanks to Luigi for the presentation. And before that, coming to us and explaining to us when we were preparing the progress report. And I will send the links also to the reports in the chat. But also, yeah, and correct. And so there they are. So indeed, I first would like to remind a bit the position of the strategy of the Commission and the EU. So definitely the principle of energy efficiency first, and so the priority to renovate and insulate the buildings and reduce their energy need for heating and cooling. Also favor the development of district heating networks, especially in densely populated areas, to really benefit from the efficient large-scale renewable heat pumps, biomass, geothermal. Also the excess heat recovery from industrial or commercial usage, and also combined with thermal storage to really contribute to electricity grid stability and this storage intraday, intra-week, or at interseasonal timescale. Then in the less densely populated areas, we favor purely electrical heat pumps in most existing buildings, all new buildings, or deeply renovated buildings, and together with smart controls to reduce the challenges of integrating them into the grid, their electrical consumption. Smart controls can shift the heat pump use to off-peaks periods, and also to self-consume any potential local PV production. Then, indeed, in some cases where the buildings cannot be easily renovated to reduce the heat demand, hybrid heat pumps, so electrical heat pump with gas boiler backup, can offer an economical alternative to high temperature heat pumps for buildings that, so for those buildings that cannot be insulated and where the heat emitters are difficult to replace, for instance, in historical buildings, and in regions with cold climates, and also in case there is unfavorable electricity to gas price ratio, or also a weak grid connection. So in that case, the hybrid heat pumps combine the advantage of being electrical, using the renewable electricity, which is to be decarbonized, but also in the cold days to have this backup at the time when we need high water temperature in the radiators. And then firing efficient gas boilers like thermal driven heat pumps on low carbon hydrogen or other gas is a way to fully decarbonize the hybrid system, but it makes only sense if we have sufficient quantities of renewables or low carbon hydrogen or other gas, because we first have to satisfy the hard to abate sectors such as industry and heavy duty long distance transport. And also,
I think that's,
yeah.
Sorry to cut you off, Rick. Yeah. That's been a minute or so more than been allocated for. I think there's certainly going to be some follow-up challenge to you on some of those points there. I'm sure we'll get to it from other speakers. There's been I think get it touched upon it. You could consider, for example, thermally driven heat pumps as the ultimate hybrid. But given I guess the position you outlined that European Commission has taken thus far, what would be your recommendation then to stakeholders within the thermally driven heat pump sector? What would be your recommendations to them to increase the awareness of the technology, to successfully help policymakers, whether it's at your level within the European Commission or at the country level, acknowledge the benefits and the benefits that this technology can offer versus all the other options? I think we're all in agreement that everything will be required, things like biogases, hydrogen, etc. What would be your advice to companies active in this market to further their expansion of this technology?
Yes, indeed. And so you see that your main competitor is the hybrid heat pump, that is electrical compression heat pump with a gas backup. And so the how to increase awareness, it's also explain a bit more what was briefly presented, but still that people need to better understand what is absorption heat pumps. I've seen the notes that you have published, the diagrams there. They are still, even though I'm engineer, difficult to understand. Not the ones that you presented just now, they are very simple, but the ones in the note are a bit more complicated. And so, as I said, it's also comparing with the hybrid heat pumps. So how do they compare in specific, in typical building topologies like apartment or houses? How do they compared to the hybrid heat pumps in different climate zones, and also with the sensitivity on the carbon content of electricity? So indeed, you presented carbon content of electricity with the primary energy factor of 2.5, 2.2. Well, if it is purely renewable, every kilowatt hour of electricity is really coming directly from the renewables, so that there the factor is much higher. So indeed, it really depends on the cases, and so making a comparison with hybrid heat pumps, and also not only with the present carbon content of electricity, but what will become the carbon content of electricity, so in the future much lower, would be a way to demonstrate your case.
Thanks, Eric. I think that's a clear statement for TDHP players there. I mean, personally, have a slightly different view on the main challenge. I think hybrids are a strong challenge for electric heat pumps. And I would say that technologies like thermally driven heat pumps are potentially, as well as decarbonised boilers and other technologies, more suited to that hard to treat, hard to decarbonise building stock that you really can't insulate, or it makes no financial sense to spend 30 to 40,000 euros to insulate. I think that's, in my mind, if I dare to say something that I feel gets a little bit overlooked at the high level of policymakers. But let's see what comes up in in the discussion later. But thank you very much for your thoughts and your input, and yes, for sharing the report. It's a really interesting, excellent report. So everyone who's on the call should check that out. We're going to now jump between different countries. I think we're going to travel. Well, you're in Brussels, so we're going to go north a little bit and hear from Germany. So we have Andreas Lucke, who is a senior expert within the German Heating Industry Association. Hi, Andreas. Hopefully you can hear us and we can hear you.
Yes.
Great. And
okay.
well,
can you hear me?
I can.
Okay, very good.
And let me just reset my timer.
Hi, Federica. Hi, Thomas, Melanie, and Luigi, and everybody else. One thing for sure, it's very, very difficult to talk about a very, very marginal market for thermally driven heat pumps in Germany. It's less than 1% of the sales. And the other thing that makes it difficult is I love the technology because of the advantages which were described recently, and I'm pretty sure Luigi will add to these advantages. And there are, in my opinion, only advantages to mention. That's the high percentage of renewables being used and being utilized. And the other thing is it's a gas-driven technology. And in Germany, we have a gas grid of 550,000 kilometers. By the way, if we compare the German gas consumption with Italy, Italy was 750 terawatt hours, I guess, and in Germany it's almost 1,000 terawatt hours. Electricity in Germany is a little bit more than half of that, 560 terawatt hours. And so everybody would be surprised that everybody is talking about electrical heat pumps and not about gas heat pumps, thermally driven heat pumps. The logic would have to be another one. On the other hand, you might also add costs. And as you know, Thomas Novak mentioned it, 12 years ago, ISH was full of thermally driven gas pumps, gas heat pumps. It was Weiland, it was Bosch, it was Fiesmann, it was BDR Thermea, it was Ariston. Everybody was on the market with this superb technology in the various with various different concepts. And today it's my very valued and very, very important big member Ariston, still active in this field, and some other smaller ones maybe. But within our Federation of German Heating Industry, the topic is unfortunately, and very, very much I disagree with that thing, but very unfortunately, it's not a big priority anymore. So I guess it's a good idea that EHPA and EHI think in terms of vitalizing this discussion. I mentioned the big advantages. And I also believe that the technology will have a good chance on markets where the frame of reference is really at looking that the gas plays an important role also in the future. Coming back to Germany, much before we had this boom of electrical heat pumps, the big manufacturers, with the exception of Ariston, stopped the production of thermally driven heat pumps. And they did it, in my opinion, because of the competitiveness and higher costs compared to other systems which for five years ago were dominant in the market and still dominant in the market. That's one thing, and it's a decision of the companies. It's not the decision of the federation. And the other thing is the frame of reference. If you look at the political frame of reference, once again, gas, natural gas is absolutely number one as energy carrier, followed by heating oil in Germany plays a very, very important role. And electricity doesn't play a decisive role, not yet, less than 10%. And now politics and politicians, especially the coalition we have now is aiming at the electrification of the heating sector. That turns everything around. In other words, it's not the gas condensing boiler, and it's not the thermally driven gas heat pump. No, it's the electrical heat pump. And last year, no, not last year, sorry, in the forecast for this year, in Germany will sell 225,000 heat pumps, electrical heat pumps. That's an absolutely a record. And that's 40% more than the year before. In no other category of heating systems has such growth rates and such a volume. The volume, excuse me, that's wrong. The volume of condensing boilers is still higher, but there the growth rate was negative by 10%. In that field of electrification as a political goal, the thermally driven gas heat pump has a very, very difficult stand. This might change, especially, and my predecessor said it already, if, for example, the share of green gases, biogas, and others, if this increases, then, in my opinion, the thermally driven gas heat pump is one of the most elegant and intelligent options we would have. And it's very easy to take up again the development of gas heat pumps because there is experience with the technology, there are patents, and so in my opinion, it has a chance. The country, Italy was mentioned as an example, and Ariston is one of the huge producers there. And it makes sense because Italy depends heavily on natural gas and has a lack of electricity. That's, by the way, also the case in Germany, but not to this extent. Okay, that's my comment on as a starter.
Thank you.
Difficult field for thermally driven heat pumps, but I see a chance for the future.
Thanks for your summary. Yeah, I think we used much of your time there, Andreas, but a really helpful overview of sort of recent history within Germany, and support for thermally driven heat pumps has come in waves. As you mentioned, they were supported through the MAP programme. They were supported up until very recently with the government grant, which is a big reason behind the sort of growth that Germany's seeing in electric heat pumps at the moment, as well as hybrids. I think we will come back to you potentially for additional points at the end. I'm conscious that there's one or two speakers that need to leave us by 3 o'clock Central European time, so I'm actually going to change your order around a little bit. Hope that's okay with yourself, Gideon, and Mario. But Mario, I understand that you have a hard stop, so we're going to jump from a country, Germany, where you could say the political situation is in flux, the heating market, the support in the future is in flux. Mario, you are based at the Politecnico di Milano, Bellini, and you're an associate professor at the Department of Energy. You're also involved in running the RE lab, Renewable Energy Lab, which supports the development of both fully electric and thermally driven heat pumps. To begin with, can you start with explaining why Bellini is interested in thermally driven heat pumps and why you're involved in helping to bring this technology through to market?
Thanks for the question, Stephen. So yes, so I'm working for the Renewable Heating and Cooling Lab at the Department of Energy, Politecnico di Milano, and there we are testing and developing. So we have got development activities for heating and DHV, so domestic hot water appliances, both electric and thermally driven. Let's say that in Italy, the scenario is very similar to most of the European countries. So tending to complete decarbonization means as well to see a deep electrification of the sector, of the heating sector as a tendency. together with the growth of the district heating, which goes in Italy by now is less than 2% of the overall demand, will be probably at the end of the transition about 7%. But it's still, let's say, figures which are not particularly significant for what the actual point in time concerns. So this is the reason why we started. So we are testing at the Relab electric driven heat pumps, hybrid systems, and thermally driven heat pumps. Let's say from our experimental experience, it is clear that for the substitution of actual generators in Italy, so, which are mainly gas boilers, in the actual building stock, which is mainly consists of not renovated buildings, it is pretty necessary to apply generators that are capable to supply a heat carrier fluid to the building, to the net heating, to the distribution network of the building, with the appropriate temperature. This means basically to couple in the majority of the Italian heating systems heat to radiators mainly. For the building, the actual building stock, for the existing building stock. So let's say, as Gerrit Völter was showing, in most of these buildings, the substitution of the generator until there won't be a complete renovation of the building and the distribution system will imply to apply mainly only either the hybrid systems or the thermally driven systems, because I mean with the electric heat pumps will in most of these cases suffer a lot in terms of efficiency. Let's say from what we tested in let's say recent projects, this constraint gives more chances to the thermally driven generators for a pure substitution, let's say, of the generator, due to the supply temperature constraint. Even more, let's say that if you look at the overall primary energy efficiency, in some cases even more than the hybrid systems, where the heat pump, the electric heat pump, suffers exactly as a normal, completely electric heat pump would.
So the ease of retrofitability is an absolutely key.
Let's say in the transition time, which is from now to the time where it's clear that in each renovated building, there are electrically driven heat pumps nowadays. We invested ourselves in know-how and activities, seeing that there is a lack in time. So there is a window in the next years where the application of the thermally driven heat pumps as a substitution of the gas boilers gives an advantage before a full application of electric driven heat pumps would happen.
Yeah, or potentially longer, given well, I think we're still waiting on understanding exactly how the European Commission's renovation wave and this flood of green finance will come into the market, and if the big banks aren't going to fund whole house retrofits and with these novel green mortgage products and make it really, really easy and straightforward for householders to borrow the extra X 10,000 euro they need. Yeah, ideally you would do all that, but we're not living in an ideal world, and I don't think we'll be there anytime soon. So the last point, and maybe if slightly more brief, Mari, was Italy. We've mentioned it's an interesting case study of a market that supported TDHP technology through various incentives, Conto Termico, Eco Bonus, Super Bonus, etc. What is your view on the outlook for the market potential of thermally driven heat pumps within Italy? Do you think Italy will remain a leading market for deployment of this technology, and could it take the next step up to higher levels of deployment?
Let's say I don't see a rationale why this would not happen. Unfortunately, if you look at the Italian subsidy systems, we have let's say a strange habit, which is not really applying rules for a time which goes above the 12 months. So it's all these subsidy systems are renovated on a yearly basis. And this is not helping out very much to plan. Not even the industrial players nor the let's say the players which normally apply, so the building developers. But let's say from a rational point of view, and actually for the actual legislation, the subsidy system includes the thermally driven heat pumps. Actually, the old subsidy system was even subsidizing the substitution of actual boilers with condensing boilers. So I mean, thermally driven heat pumps are for sure in, and it is not foreseen by now any mechanism which imposes a specific ratio of renewable heat. Even in that case, let's say there could be because I mean we have in the overall scheme for the certification there are limits, and this limitation within this limitation is it still possible to use thermally driven heat pumps. So and I don't see any potential stake coming from the regulation system. And I see that for what are the subsidy systems in force by now, which the actual government said that will renovate with the same rules. Thermally driven heat pumps, electric driven heat pumps, and hybrid systems are all in. So I see that there is no really foreseen a change in that.
Thanks, Mario. Yeah, I guess Italy's another market where it's challenging to the political situation and a period of change there as well. But yeah, doesn't seem to be any major indication that the support that's been available in the past won't continue on into the future. So thank you. I'm afraid, yeah, any follow-up that we have for you, I guess we'll address it to you following the end of the session. I acknowledge that just to say, Scott, I saw Scott Reid, you had your hand up. I think if you're able to type your question in, some comments from Chris, Abe, Alexandra, Javier. Yeah, I think Melanie and Sarah from EHP will be monitoring your input and be coming back to it towards the end of the session. To link from your point, Mario, on the use of renewable energy, I guess one thing you can say, we keep making this comparison between TDHPs and hybrids. You'll always be using some renewable energy in a TDHP. You won't always be using renewable energy in a hybrid, unless you've got a certain element of green electricity coming through the grid, or you're using biomethane or hydrogen in the boiler part. So an interesting point to consider maybe, but someone who's much more qualified to comment on the technical elements of heating systems than I am is coming up next. Yeah, sorry, Mario.
Stephen, I wanted to add something that it is a peculiarity of the Italian market that is discussed nowadays. This is in respect to the fact that we all know that there will be a trend towards electrification of the heating market. And there is a big discussion about the fact that Italian buildings have an electricity distribution system internal to the building, which is peculiar compared to other countries. And this is one of the reasons why the policymakers are careful as well and deciding towards a very fast electrification of the heating market. And the peculiarity is that the counters of Italian houses have got a limitation to 3 kilowatts in power. It is, let's say, most of the counters are like that. In the recent years, the regulator decided to give the chance to enhance this capacity, but the overall electricity system of the buildings is sized in a way that let's say can support at least 3 kilowatts for each single dwelling. This is posing a potential problem towards the complete electrification, because there is foreseen the need for in the single buildings to have an action as well on the electricity distribution system, which is internal to the building.
I see. No, that's a very helpful point to clarify. So yeah, more components to upgrade.
So if we look at potential, let's say, short market for the TDHP, which is what we are discussing today, we see that there is no doubt that in the future will be there will be a strong electrification. But what is going to happen from today to that moment, which depends as well on the capacity that we have of the building renovation that you were saying as a whole from thermal point of view, and the work on the electricity distribution, is, let's say, that these two parameters are gonna give us an idea of what is the window that will still be used by gas-driven or thermal-driven technologies.
Thanks a lot, Mario. That's some really interesting final good food for thought on the specific context in Italy with regards to what options fit best where going forward. So thanks again for your participation. As I mentioned, now we're going to go over to the Netherlands. We have Gideon Blay. Gideon is currently an independent consultant specialised in the topics of standardisation. He supports a lot of technical committee work. For much of his career, though, Gideon, you were technical director at ATAG Heating Systems. And well, I think you were going to share a couple of slides actually. So I will let you just fire on and talk us through those within the to explain the context of the Netherlands and what's happening to decarbonisation of heat there, a fast-moving market.
Yes, I will do. Thank you, Steve. Hello to everybody. I think you asked a very simple question: what is the future of gas in the Netherlands? As we talk about disconnecting towards gas, and is there a future for hybrid heat pumps or thermal-driven heat pumps? The question is simple, but the answer is a little bit difficult. But let me start by spoiling the answer. The answer is yes, there is a future. There is a future for those kind of products. And why is there a future? We have to look back partly in the past. How is the Netherlands organized? How is policy changing? And what are the latest steps in the Netherlands? As you know, the Netherlands is very, orientated on gas due to the fact we have the Groningen aardgas fields, which makes us, let's say, autonomously in our energy supply. And we started to utilize this, and we realized that in the end we could not only stay with utilizing Groningen aardgas. So we make a jump of, let's say, introducing other gases in our infrastructure through the years. And then we talk about Norwegian gas, Russian gas, and also LNGs. LNGs is a topic at this moment, but we already started in 2010 introducing LNGs as we have foreseen to be, let's say, a kind of roundabout of gas for Europe, so that we can trade with the gas towards other countries like Germany and Belgium with gas, for example. In the end, we also found out that due to the policy changing like Kyoto and Paris, we should think about sustainability, and we started to develop green gases. And green gases in this way, because I'm making note, especially on this one, green gases are in this case methane-based gases, for example, out of digestions, but also hydrogen gases, for example. So it's a container of more kind of gases. And today, to give also a position on green gas, we are producing in the Netherlands between the 200 and 250 million cube of green gas, to give an idea. We understand that in the end, there is no Groningen left anymore when the reserves go down. So we started to reduce, let's say, the energy uses in our houses, just to get lower the amount of gas we are using. And if you see on the right graph, you see how the energy we use in houses is reduced due to all kind of requirements we had on houses. Around 1995, we had the Energy Building Directive, of not so energy performance coefficient, which make the house more efficient. And you see a drop of 3,500 cubic meters of gas towards almost 2,000 cube of gas we use in dwelling in average. And this prolonged for the years, and even at 2020, we reach a level of around 1,300, 1,400 cubes of gas. So we are really reducing due to efficient technology and isolating the buildings, the gas consumption in the Netherlands. So if you compare what was our goal, 50% reduction in 2030, and let's say the reference value is 1919. If the policy continues as today, we are almost there by the efficiency we have on the buildings and on the installation, just as a remark, as a giveaway. So this is our starting point. So we have a lot of gas in the Netherlands. We're fully dependent on gas, and we're making a shift towards more green gases and also stopping with gas, to be clear. So let's see on the next slide. Oh, I can take the control. Hold on. Yeah. So let's see what is happening on the next slide, how we are developing the policy in the Netherlands. So in 2060, we make a new agenda, which is about energy and how we want to treat the energy in the Netherlands. And we look to several things, to be clear. We're looking to our industry, our dwellings, how we produce energy, and we make a program for this. And the policy of the Netherlands is always reducing CO2. So no selection for, let's say, the way we want to make the solutions, but only aiming at reducing CO2, to be clear. That's always the ground of our policy. But in the end, when we had an earthquake in Groningen, the policy changed more quickly. So we want to stop with the gas distribution. So we changed the legislation in 2018, which make us that we cannot connect anymore in the new built house gas. So this gas connection was lost. So all new built houses are now connected towards district heating or mainly electrical driven heat pumps. Mm-hmm. And it is easily to do because the buildings and let's say the infrastructure are connected and are prepared for this new build. So I see it a good solution to stop with gas if we don't want to use gas, to be clear. So we make a covenant, in a climate covenant, where we say this is the law for the coming next years, and we have to deploy it to the regions in the Netherlands. So we have 30 regions in the Netherlands where, let's say, the local administration can select how they want to cover the solution to reach, in the end, the reduction and work to the greening, to be clear. So what is the main goal? The main goal in 2030 is to disconnect 1.5 million of houses, dwellings, and disconnected from the gas grid. So that's a huge amount if you compare that we have roughly 8 million dwellings in the Netherlands. So it's a really big task to say, oh, we want to disconnect this. And one of the tasks we have also was that we want to have 35 terawatt on renewable energy on electricity. And that is, how do you call it, made by PV or wind turbines, to be clear, especially on the sea. Another goal we had as a target is to produce 2 billion of cubic meters of green gas. To put the figures in relation with the electricity energy, it's a roughly 20 terawatt hours on green gas on energy we talk about. So it's immense how we will invest, and we have set targets also for green gas. I think this is the hookup what I will make towards, let's say, hybrids or thermal driven heat pumps, because these are our targets and this can be utilized for these kind of equipments. And in the end, in 2050, we want to be climate neutral. If we go to the next slide.
Sorry to, I don't want to rush you, Gideon, but we've got maybe 25 minutes remaining of the session, and we want to get to our last panelist and the Q&A as well. So would it be possible maybe to move on to your final slide for your sort of wrap-up point on your view on the future of TDHPs in the Netherlands? Sorry to rush you on, we've gone a wee bit over time, but just want to give you the chance at least to make your concluding point before we move on.
Okay.
Thank you.
Okay, maybe to make it clear, we started to working on the programs to disconnect buildings from the gas grid. What happens there is when we get the experience, it was hard to disconnect from the grid. We run in kind of problems like the costs were too high for the customers, but what we also saw is that there was not always, let's say, sufficient support for this. So our government changed, let's say, their approach, and they say we want to do it better, and they add hybrid heating systems in towards, let's say, the parameter. So this means for the future, if we're looking to efficient heating installations to serve the targets, we want to introduce district heating, all electric, but also hybrid heating systems. And why hybrid heating systems? Because they are in balance with, let's say, our energy structure. So we have the selection towards, can we go all electric if the dwelling is applicable for this? Or when we need, let's say, more thermal heat, do we select for hybrid heating systems? And hybrid heating systems can be thermal driven heat pumps, but also the hybrid heating system like a heat pump together with a gas condensing boiler. And I think one of the conclusion and one of the points we are now is that we want to stop with the mono boiler in 2026, and that we want to offer these efficient solutions towards in the Netherlands market. So that we want to roll out hybrid heating solutions. So my conclusion, Stephen, is there a future for hybrids or thermal driven heat pumps? Yes, it is, because they can utilize the amount of green gas which we will produce in the future, and will be a good solution to speed up, let's say, the energy transition in the Netherlands.
Thanks very much, Gideon. That's tough to convey that amount of the history that the Dutch heating market has gone through over the last 10 years, but I think it's very valuable because a market where there's a significant amount of gas heating, as you mentioned. The Dutch government has addressed the decarbonisation of heat more quickly than other European countries, and therefore sort of going through a learning process that other markets can learn from. So thanks again for your input there, and we'll see if there's follow-up questions for you at the end. But our last but no means least speaker is Luigi Tischer from Ariston. Luigi is R&D Senior Director at Ariston, and Luigi, my first question for you is you've spent a lot of years developing Ariston's product, which we saw on Get It slides. What's your elevator pitch for the product? Why do you feel there's a role for it in the future of heating?
Okay, thank you for the question. I believe that there are several different reasons why thermal driven heat pump should be successful in the introduction to the European market in particular. And let me say, most of these apply to all the entire category of thermal driven heat pump. I would try to consider the benefit for the different elements of the value chain or the different stakeholders. In particular, end users, they will be running an appliance or a system which will allow them to reduce gas consumption by 30 to 40%. This is real money saving, not only energy saving. And this in many countries has an important meaning, in particular when we consider that the energy price is expected as a minimum not to decrease, but very likely to increase compared to, let me say, the pre-Ukrainian times. Second, the ease of installation. we mentioned the ability of not redoing the emission system, which is not negligible. I mean, being able to reduce the consumption of a building using and adopting the same radiators is a quite important asset. And let me say, it's not very often we say is a matter of temperature. It's not only a matter of temperature. Please remember that we need to achieve 55, 60, 65, 70. But when we achieve those temperatures, we also need to deliver power and efficiency. Because getting there, having lost the power, meaning not being able to deliver the nominal power, is a critical issue. As a minimum for the grid, very likely even for the end user, because it will be a cost in backup systems. And then efficiency. I mean, you need to be, in any case, efficient in those conditions. So it's not only a matter of temperature. The other point is wideness. We know that the heat pump market at today is limited, or in any case, identify concerns by, let me say, the level of noise of the heat pumps, very often related to the neighborhood. Now, these units, this technology, which doesn't have compressors and very often use half of the air of a regular electrical heat pump, will definitely improve this situation and will be a benefit. And therefore, the end user will not have the dilemma, should I minimize the cost or should I reduce my carbon footprint? With a thermally driven heat pump, they can achieve both. Then I believe there is another important element in the value chain, is installers. Installers and planners. They very often tend to be the decision makers, and they can see a technology which has a constant output power and easy to be installed with the certification and training that they already have. This is quite important for that category of professionals. And lastly, I believe the legislator, we discussed in the previous few minutes how important would be not to extra load the electrical grid, which in the near future will be used also for additional purposes. Think only to the electrical vehicles which are coming and which are going to load the electrical grid. And then mitigate, as I mentioned before, the lack of installers. Across Europe, we do have, at this point in time, a substantial bottleneck, even only looking at the installer. On the other side, this is also an entirely European technology, which can benefit in terms of value chain and assurance of supply, given in the particular situation we are facing. So let me say, these are some of the advantages for the different category of stakeholders.
Thanks, Luigi. As expected, you put forth a compelling argument there. My final question to you before we move on is, well, Arsene, you're in the position, you've got the product, you could ramp up production if you so wished, but we've discussed how it's quite challenging times across the European heating industry as a whole, despite the fact that businesses are doing well. We've not touched upon the component supply shortages, but that is absolutely still an ongoing issue to address and to be mindful of. Question is, what would you like to see from the European Commission or from other stakeholders in the heating industry, to give a company such as yourself confidence to ramp up production and really put the foot on the gas when it comes to market introduction?
Yeah. So let me make a statement before answering your question, and then I will come to this. As a manufacturers, we tend to develop energy conversion systems. And we want to deliver those energy conversion systems as efficient as possible to our customer. Who might select an energy vector of their preference or their possibility, because they might not have the option to select which energy vector. And it's important to decouple the concept of cleanness of the energy vector from the appliance itself, which is using that energy vector. And this is because, let me make an example. If we take today a regular boiler, not even a condensing boiler, but running on bio-LPG, which is already sold across Europe. Isn't that a 100% renewable heating solution? So you can see that there are stereotypes about fossil technologies and renewable technologies. No, I believe there are vectors that need to become greener and greener. We have a plan for electricity to become greener, and we do have a plan for a molecular vector to become greener. Now, my point, and this is to come to your answer, is that even today, we have seen a substantial difficulty in forecasting the developments over the next few years. We have different opinions, and very frankly speaking, nobody knows what is going to happen. What we have are few certainties. I mean, the renovation rate. Can we expect that the renovation rate is going to bring us all new building by 2050? Is unlikely. Very likely we will keep a renovation rate in the order of 1% per year. Is the decarbonization rate a given? Are we sure we are going to renovate, decarbonize the electricity at that rate, which will bring us 100% by 2050? Energy price, I believe, is part of the equation. The highest the price of the energy in general, electrical and molecular, the highest will be the need for efficient appliances, and so on. So there are several criteria and several factors that can affect our strategies and can change the speed at which we will be able to decarbonize. So my answer to your question is what we will ask European Commission is in particular to consider the advantages on short term of the thermally driven heat pump, on short term to boost the decarbonization of existing building stock, and on medium and long term to use this technology for accelerating the adoption of green gases. Therefore, to adopt thermally driven heat pump as a no regret option. That is the key message I would like European Commission and legislator to consider. Because there is, let me say, substantially no disadvantages in de-risking and adding one additional option to the decarbonization plan. That's all from, let me say, my answer to your question.
No, ideal. Thanks, Luigi. I think that's a really excellent point to conclude on. So thanks very much again to all the panelists. We've heard, and rightly so, a lot about why electrification of heat and electric heat pumps are being supported as well, but we all knew that. So hopefully everyone who's joined us this afternoon has learned a lot about thermally driven heat pumps and the options that are available there. And yes, we've been able to elaborate on the information that was provided in the white paper by EHI and EHPA a few months ago. Just to clarify one slip up I think I made earlier, of course I was stressing the point that in a hybrid system, if you're only using a gas boiler, not with the heat pump, that's when you're not using renewable energy. Of course, if the grid is 100% coal, you're still using renewable energy and the heat pump part of the heat pump. But at peak times and depths of winter, anyway, that's something that was bugging me. So I've addressed that. Melanie, Sarah, we have maybe 10 minutes left. What would your preference be? Shall we take some key questions, or would you like to jump straight to the polls?
Yes, thank you, Stephen. Well, I have 3 key questions that I selected while you were having this discussion.
Right.
And thank you for all the panelists for this interesting discussion. We will answer to the other discussion after in written, but we had, for a matter of time, to select few. The first question that I have here under my eyes is a question from Javier. Is the German electricity grid ready to support all electric heat pump installation planned? And this is directed to Andreas, I guess.
Yeah, thanks a lot for this question. It's a very good one, and it is in connection what Luigi reported. The big advantage of thermally driven gas pumps, it's running on molecules. In Germany, we have an electrical grid. It offers 560 terawatt hours. That's 1/5 of the German final energy consumption. We have 2 tendencies. One tendency is the government is aiming at installing 6 million electrical heat pumps until 2030 and 10 to 15 million electrical cars. And you can imagine what that means as additional demand. At the same time, the government has an electrical grid policy where they cut down the coal, electricity from coal. That's 40% of secure capacity, 40%. And then they cut off the nuclear power plants in April. That's at least the plan. That means they are decreasing supply and increasing demand. And as an economist, everybody knows that's a problem. The fact that they increase at the same time at a certain speed, electricity from wind and electricity from PV, there are two bottlenecks. One is they are fluctuating energies. So that's not a secured capacity. And the other thing is the speed of developing the wind parks and PV parks is not the speed they would have to have in order to achieve their goals. So that's a problem. And for us, it means in times where you have no wind, no sun, but very, very low temperatures, this additional demand for electricity must be matched by secured capacities. It cannot be matched by wind and PV. And then the blackout would be the result of this policy. So answering the question, yeah, the grid has a problem.
Thank you, Andrea, for these answers. Very detailed and clarifying the point. Second question that I have is from Kusura. The question is, payback time of thermally driven heat pumps are multiple in comparison to electric driven ones. And I'm not sure who should we direct this question.
I would say Luigi, maybe you want to say a few words also on cost or prospective cost.
Yeah, what is the question? Excuse me again.
So I was saying payback time of the thermally driven heat pumps are multiple in comparison to the electric driven one.
Oh, okay, sorry. Having said that, in my personal opinion, the real comparison and competition between thermally driven heat pump is not electrical heat pumps, but is more no retrofit at all in maintaining a regular boiler. If we compare to an electrical heat pump, I would expect that the largest majority of the product will be substantially aligned with the cost of the product, meaning electrical heat pump will have the same cost of thermally driven heat pump and the other way around. And the point is that with thermally driven heat pump, you might be able to generate a saving compared to a regular gas boiler. And depending on tariffs, so if we are talking about France or Germany, and therefore the spark spread, you might have a larger or smaller cost benefit in using a thermally driven heat pump compared to an electrical heat pump. This is clearly depending if we are in France, for instance, where the spark spread is relatively low, or we are, for instance, in Germany, where the spark spread got to the 5 as in the past. So really depends on the market. In general, thermally driven heat pump are cheaper to run than substantially any other technology available for heating today.
Thank you, Luigi. Looking at the time, I wanted just to have a final question, but really quickly, if possible. It is from Stefan. Does the EU take the seasonal imbalance into account? And this, I guess, this would be mostly for Eric.
Yes, so I didn't capture what was taken or not into account.
The seasonal imbalance.
The seasonal one.
Yeah, the seasonal imbalance. Yeah. Yes, so definitely the seasonal balance will be an issue, but in the longer term, when the renewables exceed well, up to 60% of renewable penetration, it is still fine. Beyond that, seasonal storage becomes needed. And so in that case, indeed, the answer is both in storage, seasonal storage, and also the need to have a baseload energy supply that can be that has to be low carbon, but not necessarily renewable. So in the projections, of course, it depends on the member states, but nuclear can remain in the equation. Definitely at European level, it does, and depends on the member states. So yeah, that is something that will have to be tackled, and the periods of absence of wind and sun, so-called Dunkelflaut, that can last for 1 or 2 weeks. That did happen in the past, so will happen in the future as well. Are really really huge amounts of energy to be provided, and so either from storage or from baseload other energy sources for electricity.
Thank you, Eric, for this quick reply. So we are running out of time. The discussion was really interesting, and I didn't want to stop you. But I think quickly we can move on to the Slido question, which we will show you here. So if you click on the link on Slido and you enter this password, these numbers, then you will have the first question that I'm starting right now. So the question is, before the webinar, did you know about thermally driven heat pumps and their benefits in the energy transition? We wanted to know a bit if you were familiar with the technology. And we'll give you a few seconds.
Yeah, we can see that quite a lot of people are answering, which is great.
In the meantime, another comment, we will of course not forget the other questions, and if you have urgent questions or further need for discussion, please contact us. Anyone who has taken part in here can be contacted further. If you don't have the contacts, you can do this via EHI or EHPA, and you will find us, and please continue the discussion with us. We had a lot of further interesting questions and remarks and comments, and quite a deep discussion on several topics, both grid issues as well as many other topics concerning the technology and the policies concerned with it. So please keep in touch, and let's discuss further.
Thank you, Gerd. Very right. We will stay in touch. I'm looking at the result. We are at the moment with 62 reply. I think we can show maybe the result.
Can everyone see the results having answered, or is it useful that I share a screen also, a separate screen with the results?
No, it's fine. I can give it.
Yeah.
Yeah, I can pronounce it. So, Stephen, do you want to take over, or should I? Do you want to comment them?
Well, I guess you've got the controls there, Melanie. Are you okay to just carry on to the rest of the presentation? Thanks.
So we have 76% of the participants who said that they were already informed about the thermally driven heat pumps and their benefits. So it's quite good. And if we move on to the last question before the closing remark that I had from you is, sorry, it's a bit slow. The second question that we had for you was, what can we do better so that the TDHP are better known, the thermally-driven heat pumps, sorry, the acronyms. And I hope that you can access now this question. Here is more to receive some feedback from yourself on how we can improve our communication around the thermally-driven heat pumps. And while you reply to this question, I think we can have the final remarks and statement. I'll let you, Steve, take over again and give the floor to our panelists.
Well, yeah, I think covered it from my side. I think it was a really informative discussion, hopefully, and we touched on the family of heat pump technologies. Let's work back through our speakers. Coming to you first, Eric, is there any succinct final point you'd like to make, and then we'll come to you, Andreas.
Hello?
You're on mute.
Oh, I think you're still on mute, Eric.
Sorry. No, no specific point to be made now.
No problem. Andreas, anything from yourself?
No, that's okay.
Okay, happy with your input. Gideon, from the Dutch perspective or the technological perspective?
No special remarks, but I see that everybody's struggling a little bit with the same problems of balancing energy in the grid and try to make the green path, which is in front of us. So it's interesting to discuss today.
Okay, thank you. Mario, if you're still with us yet, Mario?
Yeah. I'm actually fine with what we have been saying by now. I heard what Luigi was saying about the European industry, and I think there is something that as Europeans we should deepen in a discussion, which is probably not the case of discussing it further here, about the ownership that we could have in further market, heating market, which is deeply electrified. I mean, there are other industrial players in the world, not of the heating market, but of nearby markets, which are very close, that got a dimension which is at least one order of magnitude higher than our heating champions. And so from this point of view, I think it could make sense. I know that some German friends are already thinking about these issues. And I think that this is something that in general, let's say, people who are involved in the heating technologies, European heating technologies sector should start to think about to give a system answer to a potential competition with other players coming from abroad, which could dramatically change under certain circumstances our, let's say, industrial scenario.
Yeah, another point we didn't touch on too much in the discussion, but very relevant going forward, Mario. And well, I guess it falls to yourself, Luigi. You get the chance to set the final message for everybody.
Yeah, final message is I believe is very high the risk of not adopting thermally driven heat pump, given the level of uncertainty, given the level of changes we see. I remember 15 years ago, I was sitting with Thomas Novak in a meeting of the European Commission, and at that time was really hard time to get support on heat pump in general. Okay, 15 years ago, there was no support of the European Commission on this. Now, we as an industry, we need to be prepared for all possible scenarios. The comments we heard today, in particular on the seasonal storage, cannot be underestimated. When we talk seasonal storage, we talk hundreds of terawatt hours. And the cost of lithium bromide of today will be hundreds of thousands of billions of euros. is cost that is skyrocketing and is larger than the national growth of the national gross national product of Europe. So I mean, these are issues that need to be faced, and we cannot overlook this opportunity. Thermally driven heat pump are one of the many different technologies we need to put into the field to at least partially address the climate change and the reduction of gas usage.
Okay. Thanks, Luigi. Melanie, do you have any final words to wrap up? I'll hand back to you.
Indeed. I think this is all the time that we have for today. We're running a bit late, as I was saying earlier. Thank you to all the speakers. Thank you also to you, Steven, for moderating this discussion. This was a very interesting one, and I'm looking forward for the follow-up. As explained earlier, the recording and the presentation will be available on both websites, EHPA and EHI. If you want to know more about the technology, don't hesitate to follow our social media, our website. You will know more. And then I wish you a great day to all. Thank you for coming and listening, and see you very soon.
Thank you.
Yeah. Thank you
Bye-bye.
very much.
Yeah. Bye.
Thanks
Thank
to
you.
everyone.
Have a good day.
And
Bye-bye.
have a nice day. Bye bye.
And you.
Bye.